Hello, this is Scott Sklar on the first segment of the first course, and we're going to sort of do a review of existing infrastructure resiliency. So, we're going to look at existing infrastructure, a survey of infrastructure types, pipelines, electric wires, transmission wires, distribution wires, substations, telecommunications, fiber optics, satellites, cellular towers, repeaters, internet, telecom plus data centers, water treatment plants and sewage treatment plants, and pipelines for water, sewage, and stormwater, and then transportation infrastructure, railways, highways, ports, airports, and the lighting of all those and communicating within those. And then first responders, police, fire, ambulance, hospitals, medical office facilities, assisted living, nursing homes, and actually vaccine refrigeration as well. So those are what we'll cover. And I want to talk about risk. I think it's very important. Our second segment here will get deeper into that, depressingly. But this is a great slide out of Morning Consult a few years ago because it goes from 2012 to 2020, and look at how the changes are, being looked at in terms of global risks, extreme weather from climate change, which we will discuss in the last segment, and involuntary migration before that, which, by the way, is wars, sometimes dealt with by cause of water scarcity and climate change. And then, imbalances, you see extreme weather and climate risks. And so I really want you to take a look at what these issues are, because the natural disasters, climate risk, war, extreme weather, all cyber attacks, all impact this set of infrastructure. I love this. This was done by one of the environmental groups in an award program, and this was one student's look at climate-induced issues, so on fire in the West and hurricane terror and hot soup of air and, by the way, tornadoes in the middle have nothing to do with climate change, by the way, but it's in there. Nor do earthquakes. But at any rate, it just shows what's going on around the country. So I want to put in context, too, that we're now, as of last October of last year, we have over 8 billion people on the planet. And I want to put this in perspective. When I was born in 1950, we had about 2.5 billion people. So we added 5.5 billion people in one lifetime. And there's another slide I don't have here, but it's as important, is also, as of about a decade ago, over half the world's population is urbanized, where in 1950s, 80% was basically rural. So not only is the population growing exponentially and quickly, but it's urbanizing, and urbanizing means it uses more energy per capita. If you're poor in a poor country and you're living on a farm and, your water system doesn't work, well, yeah, you can go to the lake with a pail and get your water. So, and if the sewage system doesn't work, you can pee in the forest. But you really can't do that in an urban environment. And that's really the tensions and the greenhouse gas drive that we're seeing around the world. So again, we're going to review network grids, electric power lines, natural gas oil pipelines, communications, smart phone lines, cellular towers, repeaters, cable TV, water, sewage, and pipelines, as I mentioned before, railways, roadways, riverways, and data centers and the internet. And I want to point out, though, this has got to be very important. And we'll discuss this a little bit also when we cover water. But our energy system, the electric grid, is very reliant on water because most of our power plants are thermal plants. They turn water to steam. And our data centers are reliant on the internet, of course, which is reliant on the telecom system. So there's a lot of mutuality, and of course, our water and sewage systems and our transportation systems and our energy systems are relying on the internet now. So this mutualness is really very important for you to understand. At one point in time, before the year 2000, most of them were, in a sense, fundamentally separate, except maybe for water and electricity. Now, all of these are seriously intertwined. So, before we really get into this certificate course, I want to put my issues out there. When I'm asked, how do we make infrastructure more resilient, we need better building codes because buildings last for 100 years. Cars are great, but they'll last maybe 10, 15, 20 years really. But buildings, 60 to 125 years. So what you do in buildings is important. Prioritizing help for low income and communities that are more climate vulnerable. Because generally they're relegated to the worst areas, not the best areas. So they get more ocean surges and flooding and pathways to storms. So we need to think about that. Additional funding for weather satellites, remote sensing, technical assistance, so we get data. We know what's going on in real time. By the way, most utilities don't even know there's an outage till they get a phone call. That's ridiculous. And we need to change that. We need increased climate change and extreme weather research. We got to learn how to make things more resilient, not just deal with greenhouse gas outputs. We need, one of my courses I teach at George Washington University is out of the graduate school in urban studies. And so we need sound land use and management practices and listening to community needs and issues. So we're planning better on what goes in. For instance, when I get called into a project, a big solar in rural areas, I will not support a solar project that isn't agrivoltaics, meaning up way high, so you can plant crops or raise animals or pollinators beneath the panels. Not only does it preserve the soil and keeps the agricultural character and integrity, which we need, and actually increases moisture a little bit, but also get clean energy. So again, figuring out how to get more with less. Linking federal recovery assistance to climate resilience planning and investment, and risk-based pricing of insurance is appropriate. We don't want to keep just pumping money in places that will just be washed away every other year usually. So let's get into some pictures. So the top left are sewer pipes. The top right is a big oil pipeline. The bottom left is FiOS. The middle bottom is big transmission utility lines on those big metal towers, and then cable TV. So you're getting a sense of the different grids and what they look like. This is our transportation grids. Airports on top left, bottom right is river ports, our railways, and then bottom left and top right is our highways. Railways, by the way, most of the rail cars were to move coal around. But now that coal's gone in a decade from over 50% to below 20%, guess what? Most of our railways now have eclipsed coal for Amazon-type deliveries. So our railways are different now, and hopefully our carbon-intense fuels will go close to zero. This is a Morning Consult map. Nuclear power plants weren't built for climate change. Now, what's interesting is nuclear power plants are always near water because they need an immense amount of fresh water to cool the heat coming out of the steam generators. Remember what coal and heavy oil and natural gas and uranium nuclear have in common is all they're there is to heat water to steam, turn a steam generator. But nuclear power plants are much higher temperatures, so they need a lot more clean water. And so they're really always near water. And of course, water, you have sea level rise and flooding where there's water. So that's a real issue. And I have lots of examples of nuclear power plants closing down because of flooding and hurricanes, which you'll see in the next segment. Um, Refineries, so where we get our oil and where we ship most of our oil and natural gas actually is along the eastern coastline of Texas and then Louisiana, and of course that's Hurricane Alley. So this is an article in 2017. As of yesterday afternoon, 20 refineries in the Corpus Christi and Houston area are offline. Combined capacity 2.2 million barrels a day, 12% of the U.S. total, according to the Department of Energy. And this is, and we have had with Hurricane Maria and others even more offline. Our communications and internet system, our part of our communication system is 100% solar powered. That's the top left satellites, and they have been that way for quite a few decades, and they work great. And as we moved off copper wire to fiber optics, and then we moved off to distributed communication cell towers on the bottom right. And cell towers, I spent a lot of time making them with battery banks, renewable energy powered, solar, wind, small hydro, biogas, and energy storage. And of course, the lower left are data centers, and they are relying on electricity. They need cooling, which uses a lot of energy because they run very hot, and they need an operating communication system because a data center where you can't send data is useless. And when I was born in 1950, of course, we didn't have data centers, and now over 10% of U.S. electricity is for data centers. So big change in our economy on that and need for energy. This is the map of pipelines in the Gulf of Mexico, where we get most of our oil and gas, both pumped and shipped and pipelined. So there it is. And of course, when you're in Hurricane Alley and sea level rise, that's pretty much threatened. So this is about an executive order on floodplains, looking at department and agencies to modify floodplain data for development and for where government supports things. You don't want to keep supporting things that get flooded all the time. So there you go. So in all my classes, by the way, all of them, I always highlight the book Brittle Power, done by Amory and Hunter Levins. And it was the first book in the modern era of energy, right after the 74 oil embargo in the 80s, that talked about how fragile our energy system was. And I actually put in these slides, I just took the table of contents out, but it's a fascinating discussion of looking at natural events, deliberate actions, mistakes or human errors, command and control communications disruptions, how complex systems fail, unpredictable interactions, tracing high-order consequences, surprises, what makes energy systems vulnerable, dangerous material, centralization of supplies, long-haul distances for coal, for instance, limited suitability of synchronous grids, 40 interactions between energy systems, high capital intensity, specialized labor requirements, potential misuse of energy distribution, and case studies like the 1977 New York City blackout and everything else. So I don't want to go over it. The book is for free. You can download it from the Rocky Mountain Institute, rmi.org. But, LNG terminals and tankers, of course, our reliance on the Middle East, even though now we are the largest oil and gas producer in the world. and national security implications. Of course, it all ends about brittleness and resilience. So this came out this year, and this is FEMA's new Federal Emergency Management Agency, which is under the Department of Homeland Security. This is the agency that responds to emergencies, hurricanes, floods, ocean surges, and of course, non greenhouse gas emergencies like tornadoes and earthquakes. And so they are now having a new approach to funnel climate change resistant funds into 483 community disaster resilience zones. And they're really looked at by the issues they're facing, what the needs of the community are, and how we can deal with that. So this is pretty important. It's a very significant approach to how the U.S. government rebuilds itself after events and its infrastructure. And what we learned after Hurricane Sandy, for instance, in the Middle Atlantic states, is the ocean surge. Well, guess what? Most of our cell towers and most of our fiber optics for data centers and telecom were right there at the coast where the ocean surges were going to come, and 100% chance to bring it down. Well, we got to rethink that. We got to either move it or vault it better and figure out ways, because it's not going to get any better. It's going to get worse. In addition, a lot of the world, and including ourselves, gets energy out of the Middle East. We're fighting the Houthis right now in Yemen, dealing with the Red Sea and Suez Canal access. We have access out of the Mediterranean, Black Sea. We have the China Sea. We have a lot of places that's small where there's saber rattling, and being reliant on particularly liquid and natural gas energy from faraway places for everyone doesn't make a lot of sense, even if there weren't greenhouse gas issues, which there are. This is a great article. Also, 2024, critical infrastructure sinking along the U.S. East Coast. It is. Sea level rise is happening. Ocean surges are more frequent. Heavy rains, as you know, are also happening. So we are seeing things sink, and that makes it unstable. So we really need to deal with this, and this is a very important article for you to read. And I want to remind you something. Most of the people on this planet live on the coastlines. That's true in the United States. Most on the east and west coasts and the coastline of the Great Lakes and the Gulf of Mexico. That's where most people live. There are a couple anomalies to that, but generally that's it. So you have very exposed infrastructure, and it's going to get worse. And this article sort of discusses the vulnerability and stretches across landscape. And this is, for any of you in urban planning, land use planning, this is a very important article for you. This next one is total U.S. exports of liquid natural gas. 10 years ago, we were not a global exporter of liquid natural gas. And now, Congress voted a little over a decade and a half ago to finance and permit export ports, which we have in Virginia and Louisiana and Oregon and Texas. And we are now the largest exporters of natural gas, I think, and then Qatar is. So there it is. So they're operating, our U.S. LNG export facilities are operating at full capacity in the last 5 years. There have been a total of 1,486 cargo LNG exports from 6 major U.S. terminals. So, and again, these are the same choke points they go through that the prior slide has. So, we've had a lot of fights over pipelines, but I want to remind you, and again, the next segment you'll see a lot of these disasters, I catalog their pictures. But according to the Center for Biological Diversity, there have been 8,000 significant pipeline incidents in 1986. Significant is delivered by the Pipeline and Hazardous Materials Safety Administration as incidents where someone is hospitalized or kills or damages more than $50,000 or more or more than 5 barrels of highly volatile substances or 50 barrels of another liquid released into the environment where the liquid exploded or burned. So there it is. Pipelines are proven to be unstable. They explode on the average of every 11 days in the United States. I want to say this again. They explode on the average of every 11 days in the United States and lead to a fatality every 26 days. So there are some links for you on that. You'll see a lot more in the next segment. This is electric grid and major transmission lines. This particular article is done, this chart is put out by General Accounting Administration, GAO, which reports to Congress. And these are high voltage transmission lines in the United States by voltage class. And these are all high voltage, longer transmission, and then it goes to substations, down to distribution lines, and then to buildings. And this one particularly was looking at electromagnetic fields or geomagnetic fields from the Earth, from the sun, and from weapons, actually. And you can bring down the grid that way, and we are trying to make sure, harden that so that doesn't happen. But, of course, on our grids, we have tractor-trailer trucks crashing along highways to hit the poles that these high transmission lights are on, and we have squirrels shorting out transformers, and we have terrorist incidents, and we have human failure, and we have cyber events, all of this making it very complex and dangerous. In addition to our power lines, we have pits and ponds from fracking oil and gas that are open in the United States. These aren't all of them. These are just the biggest ones. And they're in open air. And, of course, birds go in them. And hurricanes and tornadoes have come through and taken the water out of them and spread it around on agricultural areas and some towns. So we have vulnerabilities of our wastes as well as our pipelines. So this is looking at, from Statista 2019, 400 billions on seawalls in the United States up to 2040. Florida, of course, hanging out there, dangling in the ocean. But a lot of the folks along the Gulf of Mexico, clearly along the East Coast, and of course, California and Washington State on the West Coast. So seawalls are the short-term play that we have to do because we're going to lose some major cities. And remember, cities are cities because they're either ports on the water or at intersections of railroads or riverways. So, most of them are near water. So this is out of Federal Emergency Management Agency 2022, and this is looking at ice storm risk. And so red's very high, orange relatively high. So you see Texas in there and Oklahoma and up in the Midwest, a little bit in North Carolina, Virginia, South Carolina area, New England coastline, some up there in Idaho and Oregon. And then relatively moderate, the yellow, and, we don't have sufficient data in the gray. Most of that's a desert. So there are very warm areas. I know I've seen ice in Miami, but not often. But as we get extreme weather events, icing, particularly on power lines, and of course the Texas grid went down primarily because the pipeline pumps for natural gas and the water pumps from nuclear power plants froze, and therefore they didn't work. It got blamed on wind turbines, but that's not really true. So, and then this is more on electromagnetic